Let's take a look at some of these definition of the derivative homework problems. And when we're dealing with the definition of the derivative, to find the derivative, we have to use this little formula here in the yellow box here, right? So what we're going to do with that formula is we're actually going to plug functions into that formula. I often find that students need to understand this first part right here, f of x plus h. Once they understand that, then the rest of the problem isn't too bad, but it does require quite a bit of algebra to finish off these problems. All right, so let's figure out what is f of x plus h. Well, first, let me just kind of start off by writing the original problem, which is 1 minus x squared. And then just below it, what we're going to do is we're trying to replace all the x's with x plus h. Okay, so if we apply that, we get 1 minus, and then we'll have a bracket there. Now the x will now be replaced with x plus h. And then I just square that. Okay, so as you can see, this x was replaced now with x plus h. So this thing right here represents that part right there. Okay, so let's go ahead and now let's go ahead and finish off the rest of the problem here. So let's start off by writing out the limit as h goes to 0. All right, and we want to deal with this part right here, and essentially I know that we're taking this x plus h and we're plugging that into the original function. So if we do that, we get 1 minus bracket x plus h, and I close the bracket, squared, and then we have a minus sign, so let's put a minus sign right there, and then we're minusing the original function, which is f of x, right? So our original function is all of that. Okay, so I'll put a bracket around that, and I have 1 minus x squared, close the bracket, and then I divide by h. Okay, so there we go. This is why we're plugging functions into this formula, and that's how the definition of the derivative works there. So once again, this part here in blue, if I just erase all the colors here, is this function right there, right? That's f of x. This h is obviously that h right there. And this part right here is really the original function, and that's really, we're replacing all the x's with x plus h there. Okay, with that being said, now let's go ahead and see if we can finish off the rest of this problem here. And what we need to do now is we need to go ahead and apply several algebra steps here. So every time we do an algebra step, we have to write the limit statement here. So limit as h goes to 0. I have a 1 here, minus, and then let's take a look at this part here, x plus h all squared. So if I expand that, that's going to be x squared plus 2xh plus h squared. So we're basically applying the square double square technique there. And then this minus sign can distribute into the brackets. So I have -1 plus x squared, and then we're dividing all of this by h. So as you can see, we have quite a bit of algebra steps in these definition of derivative problems here. Now there's a minus sign there, and now we can distribute that minus sign into the brackets. And on our next line, we have 1, then minus x squared, and then we have another minus sign, minus 2xh, and then we have another minus sign of h squared, and then we have the back end here, which is -1 plus x squared. Now when you're doing these kind of problems, I would say a lot of things will cancel out. So let's go ahead and write the limit statement over here. So that gets really annoying when we have to do this every single time. And now let's look at the numerator where we can collect and cancel like terms. So I have a positive 1 here and a -1, so that will cancel off. I have a negative x squared here and a positive x squared there, so that will cancel off. So at the end of the day, once I cancel off all the like terms or combine the like terms, I'm left with a -2xh and another -h squared. And that's all being divided by an h. Okay, and then from the numerator here, I guess I can factor out an h there. So if I factor out an h, I get bracket -2x minus h, close the bracket, divided by the h, and I still have my limit sign over here as h goes to 0. And now I can see that this h and this h can cancel off. All right, so maybe I'll just erase that using my pen here. And then finally, I can do a direct substitution step here, so that goes to 0. So my final answer here is I have -2x minus 0, and that's just going to be equal to -2x. And that right there is the answer to the first question there, -2x. So now I have a rational function here. So once again, I need to deal with this f of x plus h, and all that means is that whenever you have an x, that the original function in the x gets replaced with x plus h. Alright, so let's go ahead and apply the limit statement here. So this is the limit as h goes to 0 of 1 over, so x squared will be replaced with x plus h, so x plus h all squared, and then plus 1. Sorry, then plus 1. And then minus the original function, which is 1 over x squared plus 1, and then we divide that by the h. Okay, so this is a problem that we're dealing with now. And what I'll do here is we'll do the crisscross smiley face method. So x squared plus 1, that gets multiplied over here. So if I multiply that out, I get bracket x squared plus 1. And then I take this denominator here and I multiply with the 1 in that direction, so a negative sign. And I'll put a bracket here as we have just x plus h all squared, and then the plus 1. And then I'll close that bracket off. And then that will be divided by, and then what we do here is we just multiply the two denominators there. So let's have the x plus h squared plus the 1. I'll put a square bracket around that, a square bracket around that, and we're multiplying that with the x squared plus 1. And I'll put a square bracket around that. And then we're dividing this whole thing by h, right? And we know the h can just multiply with the denominator there. And I will just put the h out in front here, just to make it very clear. And I'll get rid of all that. And then we have our limit as h goes to 0. Okay. All right, so there's a few things we have to do here. We need definitely we need to clean this up by simplifying the numerator, and hopefully once we simplify the numerator, something will cancel out. Let's take a look at this the x plus h all squared. So if we apply the square double square technique, and this is where you might want to watch the video before you start writing things down in your notes. If I apply the square double square technique to the x plus h squared there, we get x squared plus 2xh plus h squared, and then there's a plus 1, right? So if I just erase all this, I can now have x squared plus 2xh plus h squared plus the 1. Okay, and then we notice that there's a minus sign here, and then that will distribute into everything in the brackets there. So the best way to, if we distribute the minus sign, I guess we get negative x squared minus 2xh minus h squared minus 1. All right, so that's what happens if I distribute that minus sign into every single term in that bracket, right? So let me erase all this now, and we'll replace that with negative x squared minus 2xh, and then we have a minus h squared, and then a minus 1. Okay, so we're slowly just decomposing the numerator there, and we can definitely get rid of these brackets over here, right? So get rid of those brackets now, and now we can collect like terms. So x squared and negative x squared, that definitely cancels out. Then I have a positive 1 and a negative 1, right? So all of that just cancels out. So let me just erase all this now, and let me just kind of move this forward to the front. So I have 2xh, it's negative 2xh, and then minus the h squared. Alright, so there we go. We've simplified quite a bit. And then if I take a look at the numerator again, I have negative 2xh minus h squared. We can also factor out an h from that. So if I factor out an h, I get negative 2x minus an h. Okay, so quite a bit of algebra here. So once I erase all that, now I have h onto bracket negative 2x minus the h. And then now I see that this h and this h can finally cancel off, so I can erase this and erase that, and I think we're good now. So now all we have to do here is we can just now we can do what we can do now is we can substitute h equals to 0. So anytime you see an h, all these h's just go to 0. So the numerator is now going to be negative 2x, all divided by. And inside that, inside the green brackets there, sorry, I'll change this back to green. Inside the green brackets there, we have a bracket x plus 0 squared plus the 1, and that's being multiplied by x squared plus 1. Okay, and then if I take a look at this right here, x plus 0 is going to be x, and x squared is just x squared, right? So I have an x squared there. And I noticed that this bracket and that bracket are pretty much the same thing. So if you want to combine that, I get negative 2x all over bracket x squared plus 1 all to the power of 2. Okay, so that's one way where you can kind of write the final answer for that one. And that should do it for that particular question. And let's move on to another one now. Okay, let's take a look at this square root example here. Okay, so once again, we're going to apply the definition of the derivative here. So this is the limit as h goes to 0. And basically this x plus h basically means that anytime you see an x in the original function, so let me kind of write this out. So anytime you see an x in the original function, that part gets replaced with x plus h. And then there's a squared there, and then a plus 1. And then minus the original function, and the original function is just x squared plus 1, and then we divide the whole thing by h. Okay, so this is what we have right here, right? So that's looking pretty ugly there. And what we could do possibly in this question is, I think we should definitely multiply the top and bottom by the conjugate. So let me put a bracket around here and here, because now we're going to multiply by the conjugate, which is the square root of x plus h all squared plus 1, and then minus the square root of x squared plus 1. All right, so we're multiplying the top and bottom by the conjugate, right? So sorry, the conjugate is plus, right? So plus, and then the square root of x squared plus 1. Okay, all right, so when we're doing these limit problems, lots of steps for these kind of problems here. So limit as h goes to 0, and if I look at the denominator here, all of the h times all of that, I recommend just clumping it all together here. So we're not going to distribute anything, we're just going to rewrite everything as is. So x plus h all squared plus the 1, and then we add that to the square root of x squared plus 1, and then we close the bracket off. Alright, and then let's take care of the numerator now. What's going on the numerator there? Alright, so let's multiply the conjugates here. So if I take this expression here in yellow, and if I multiply it with this expression over here in yellow, basically it's the same thing. The same radicals being multiplied with each other, so what really survives is just the inside, which is x plus h all squared and then plus 1. And then for conjugates, we look at the last terms here, and we just multiply the last terms together, right? So we have the same radicals, but with the minus sign, and then we just have the insides left, which is just x squared plus 1. Okay, so there you go. That is looking a lot better now. And once again, if you're watching the homework help video guide, I would actually pay attention to the next few steps before writing anything out. What I noticed here is I have x plus h all squared. So if we went ahead and expanded that and collected like terms using the square double square technique, I get x squared plus 2xh plus h squared, and then we have that plus 1, right? And then if I distribute the minus sign here, there's the negative x squared and then minus the 1. So from here I can see that this and this will cancel off. I see that this and this cancels off, and I'm just left with this. This is what basically survives if I expand and collect like terms. So let me just erase all this now. So I have 2xh plus h squared, okay? And then if you think about it, we can definitely factor out the h, right? So both terms have an h, right? So we can factor out the h. If I factor out the h, I get 2x plus h. Okay, so now I can update the numerator one more time and get h times 2x plus h. Okay, so I'll erase all this. And this is looking pretty good because this h and this h, they can cancel off. So that cancels off and that cancels off. So let me erase that now and erase that now. And now we can apply a direct substitution step where h goes to 0, right? So anytime you see an h now, the h's all go to 0. So on the numerator, I have 2x. And then on the denominator, I have the square root of, okay, so let's just see if we can do this part right here. I mean, we're saying that h goes to 0, so that will be x plus 0 to the power of 2, which is just x squared, and then plus the 1, and then plus the same thing, which is x squared plus 1. Okay, so the denominators, they pretty much look the same. So there's a coefficient of 1 here and a 1 there. So 1 plus 1 is going to be 2 times the square root of x squared plus 1. And then finally I see a 2 and a 2 there. That can cancel off, and that gives you now x all over the square root of x squared plus 1. Okay, so that concludes this homework video guide.